maybe. There we go. Okay, so today we're going to talk right triangle trig word problems. So we're going to still be using sine, cosine, and tangent to find missing sides and missing angles and things like that. But we're going to be talking word problems this time. And so in order to talk word problems, we do have to define a little bit of vocabulary, remind ourselves of some of it. So with that, go ahead and grab your notes. And we'll get going. 9.6, right triangle word problems. And a lot of people actually find right triangle word problems to be a little bit easier than your typical right triangle problems with just a triangle. It could be because we've already spent time on right triangle problems themselves, and so these ones end up just kind of being either an easier version or a version where you're only asked for one missing thing, and so then it's at least simpler to solve for. Some people also like them just because they're more entertaining. You can do right triangle word problems about pretty much anything, which I'll show in a moment. Okay, so let's start off with a little bit of vocab reminders. Some of the vocabulary will be new, some of it will be stuff that you've probably heard before, like horizontal and vertical. Horizontal is side to side, like the x-axis direction. So if I'm telling you that something is 20 feet away horizontally, then we know that we're talking about this direction, not this direction. We have vertical. So like on the wheelchair ramp problem, vertical distance was the straight up and down distance. And then just distance itself tends to be diagonal, like if something is, if a person is 10 feet away from something, typically, or that could also mean diagonal. It kind of depends on the context of the problem and if the words horizontal or vertical are mentioned. So we have that. We have angles of elevation and depression. So angle of elevation is an angle going up. Angle of depression is an angle going down. However, when we talk angles of elevation and angles of depression, if I've got like a person that's standing up here and I've got a duck, like that one problem that's down there, the angle of elevation from the duck to the person is this bottom corner angle here. The angle of depression from the person to the duck is the same angle as the angle of elevation from the duck to the person. Because if these two sight lines here are parallel, or these horizon lines, sorry, are parallel, then this is a transversal and these are alternate interior angles. So these two angles are the same. So whenever you're asked for an angle of elevation or an angle of depression, however your triangle is drawn, you can usually solve for the bottom corner angle and be okay, because it's the same angle. So those are kind of some things that will help us with our right triangle word problems here. Horizontal, vertical, angle of elevation, angle of depression. All right. Then most of the trick here is making sure we draw a good picture of what's going on. Sometimes the problem will come with a picture drawn for you, and sometimes you will be responsible for drawing the picture. So whatever happens, whether you're given a picture or not, the first step of any right triangle word problem is to make sure that there is a right triangle in the picture. So if there is not one, you want to draw a right triangle. Now, a lot of right triangle word problems, you can get as fancy as you would like to with your artwork, or as unfancy as you would like to. As long as you know where things are located, you can just draw a simple right triangle and roll with it, as long as you label your sides correctly. Or you can, like if there's, in the case of the person and the duck problem, you can draw a little person up here so that you remember that this is where the person's located, and you can draw a little duck down here so that you remember where the duck's located and stuff like that. So for this particular set of problems, you'll get to see some of my wonderful artistic skills that consist of mainly stick figures. But the nice thing is you can do right triangle word problems, like I said, about just about anything. So I'm looking for suggestions here. What do we want to do a word problem about? If I know something about it, then we can do it. Any suggestions? Could be anything from penguins to giraffes to the school to coronavirus. What do we want to do a word problem about? All right, yeah, we can do one about a giraffe's neck. I like it. Okay. This means I have to draw a giraffe's neck. All right, so the first example here. We have a giraffe. And for this one, we're going to do the kind of problem where the picture is given to you. All right, so first we have a giraffe. And our giraffe has a neck. And he wants to munch on some leaves on a tree. And let's see. We are going to say that the giraffe's neck is, how long are giraffe necks? I don't know. We're going to make something up. This giraffe's neck is 8 feet long. And the giraffe is standing a horizontal distance of 10 feet from the tree. Or not 10 feet, sorry. We'll go 5 feet from the tree. And we want to know, what is the angle of elevation of the giraffe's neck? Goodness. ELE. All right, so your drawings can be as involved or uninvolved as you would like. If you would like to just draw a triangle, by all means you can draw one, because as you can see, we do get roughly a right triangle here. This would be our angle of elevation of the giraffe's neck. So if you want to, you can pull from this just the triangle itself and get, we have 8 feet, we have 5 feet, we have the angle that we are missing. Or you can look at it as the word problem here, or as the picture problem, like that. It doesn't really matter either way, you're looking at the same kind of triangle. So now we can proceed to solving for the angle just like we did in all of our other right triangle angle problems, using our inverse, sine, cosine, or tangent. So it might help to write down again SOHCAHTOA on top of your paper to remind you what sine, cosine, and tangent are used for. Ouch, just whacked my knee on the desk. Good job, Lindell. Okay, so we have two sides here, and we have this angle that we're looking for. So to the angle that we're looking for is 5 opposite, adjacent, or hypotenuse. What's 5? Somebody help me out here. What is 5? Adjacent. And then 8, what's 8 going to be? Hypotenuse. Thanks, guys. We have adjacent and hypotenuse. So am I using sine, cosine, or tangent? Cosine. Yep, because cosine is adjacent over hypotenuse. So in this case, since I'm looking for a missing angle, in fact, I'm going to use cosine inverse of adjacent over hypotenuse, so 5 over 8. And that's going to equal the measure of angle x. So now all I have to do is type into the calculator cosine inverse, and wow, we can't see that calculator very well. We'll use this one, even though the battery is low. Cosine inverse of 5/8, which gives us 51.3 degrees if we're rounding to the nearest tenth, which in most cases you guys will be rounding to the nearest tenth. So there we go, 51.3 degrees, and we're done. That is the angle of elevation of the giraffe's neck. So on most of these word problems, you're only going to be solving for one thing, which is what makes them a little bit simpler. The only thing that makes them a little bit more difficult is when you either, 1, you have to make your own picture, or 2, you have to look at the picture and be able to see the triangle. So that's what we're going to be working on today. Any questions with this one? Any numbers we're not sure where they came from? Steps we're not sure how they happen? Okay. So we're going to do another one. Anyone have something else they'd like us to do a problem about? I've done ones in the past about Spider-Man, or see, we've done Batman. We've done someone driving to school. What else do we want? I can't think of anything. I can pick one if you want. We will do one with we'll do one with Spider-Man. Okay, so this will be another one where you guys get the picture. And then on the next one, we're going to do word problems where you'll have to draw a picture to go with it and kind of do the whole decoding of that. So for this one, we've got Spider-Man is on a building. Let me see if I can find some blue and red here. All right, so there's Spider-Man on one building, and he is going to jump to another building. Like that. Okay. And we are told the angle of elevation from the first building to from the second building to Spider-Man is 32 degrees. Zoom in a little here. All right, angle of elevation from the building to Spider-Man is 32 degrees. And the distance between the two buildings is 20 feet. How far does Spider-Man have to jump? Okay. So when we're trying to figure this one out, given the information that we have, the variable, the side that we're missing or whatever it is that we're missing might not be labeled for us. So we would have to look at that. How far does Spider-Man have to jump? Well, that distance is probably represented by this line of he's jumping from here to here, right? So this is the distance he has to jump, not this and not this, because we already have this value. So the distance he has to jump is represented by this side here. We also know that this is the right angle of our triangle here. And if you want to, you can pull this triangle off and just look at the triangle. And to do that would look like this. You've got your angle here. You've got 32 degrees. We know that this is 20, and we are missing this side. So these two, we got the same triangle going on. It's just that this one's got a picture drawn around it. Okay, so how far does Spider-Man have to jump? Well, now we want to figure out, are we dealing with opposite adjacent hypotenuse to this angle here? And we only have to focus on these two sides that we're looking at, the one that we don't know and the one that we do know. So the one that we do know, the 20-foot long side, is that opposite, adjacent, or hypotenuse to 32 degrees? Adjacent. And is the missing side opposite, adjacent, or hypotenuse? Hypotenuse. So if we're working with adjacent and hypotenuse, are we going to use sine, cosine, or tangent? Adjacent and hypotenuse. Cosine, exactly. So we're going to go cosine of the angle, 32, equals adjacent over hypotenuse, so 20 over x. And for those of you who have been working with these for a while and have noticed the pattern that whenever the variable is in the denominator, you end up taking this number divided by the trig value. Feel free to jump to that step. But if you prefer to write your steps out, we multiply by x on both sides to get rid of the denominator here. We get x cosine 32 equals 20. And then we divide on both sides by cosine of 32. So then, in our calculator, we do 20 divided by cosine of 32. And we get 23.583, which rounds to about 23.6 feet. The difference also in these ones is that sometimes you do have to include units. Like if it's a unit of length here, we know that this is in feet. This side length will also be in feet. So we want to keep that in mind as we go through these sort of problems. Any questions off of this one? Any numbers we're not sure where they came from? Any steps we're not sure how they work? I'll leave that there for a moment, make sure everyone's done writing. We're going to do at least one more, but this time we're going to do one where the problem is written down and we have to get a picture from it. Okay. And so for this particular next type of problem, we're going to use something that at first tends to confuse people when they're drawing the picture. So, or there's a lot of kind of common mistakes on. So example number 3, we're going to write out this word problem here. So this might take a minute, but we have a 30-foot ladder is leaning against a house or a building. It forms a 68-degree angle with the ground. How far up the building does the ladder reach? Okay. So this is a really common type of problem that you'll see a lot because ladders leaning against buildings make really easy to see right triangles. So the only thing that some people tend to have a problem with is that when you say a ladder is leaning against a building, some people, for whatever reason, draw the ladder straight up and down. I don't know about you, but I don't want to climb on that ladder if it's straight up and down against the building. If you've got a ladder, it's supposed to lean against the building, so it's supposed to be slanted. So when I'm drawing the picture, if you want to draw the building, you can. If you want to, like, make a picture, you can make the picture as involved or uninvolved as you would like. You can make a building, and you can make the ladder leaning against the building. Just make sure that the ladder is the slanted side. In ladder problems, the ladder is slanted. And then we've got the ground. So we can see this right triangle that we'll get here. So that's the kind of idea we're looking at when we talk about the ladder problems. So we have a 30-foot ladder is leaning against the building. So 30 feet is how long represents the length of the ladder. So we need to make sure that we label the ladder side as 30 feet because we have a 30-foot long ladder. It makes a 68-degree angle with the ground. So the ladder and the ground would be these two sides. They make a 68-degree angle. How far up the building does the ladder reach? So basically, how high am I going to get off of the ground using this ladder? That would be this side here. That's how tall the ladder gets off the ground, or how high up the building it goes. So a lot of this is just kind of decoding what's going on in the problem. And so if you want to, you can just draw a straight up right triangle here. You just have to know, and you might want to label or something on your picture that this is the ladder, the 30-foot ladder. This is the ground, this is the building. Okay. So then we want to set up a problem that goes with this. So now I can start labeling my sides with respect to this angle that we know. So x and 30 are the two sides I'm looking at here. Is x opposite, adjacent, or hypotenuse? Opposite. How about 30? Opposite, adjacent, hypotenuse? Hypotenuse. So if I'm working with opposite and hypotenuse, which trig function should I use? Sine. You're way ahead of me, Jade. All right. So sine of 68, because the angle always goes inside, equals opposite over hypotenuse, x over 30. So this one's the nice and simple case where x is not in the denominator, it's in the numerator. So all we have to do here is multiply by 30 on both sides. And then we can type into the calculator 30 times sine of 68. So into the calculator, 30 sine 68, enter. And we get 27.8 for x. And that would be feet. So if you want to add the units on there, that would be a good idea. Okay. Any questions with that one so far? I'll let everyone finish writing there. Okay. In the poll section, I want to see how you guys are feeling about these so far. So on a scale of 1 to 5, how are we feeling about these right triangle problems? 1, needing a lot of help. 3, I just need some practice. 5, these are really easy for me. What are we feeling? I would like everybody to vote. It's really hard to tell from people's icons what we're feeling. All right, thank you to the 9 of you so far who voted. Please, everybody go vote. I'm the only one who will see what you responded. You got 30 seconds. Ten seconds. Okay. So it looks like we've got a vast majority 3s with some on either side, tending towards more the 4 and the 5 end of things. Okay. Thank you to those of you who voted. I think what we'll do now is I'm going to put up the homework assignment and then we'll talk through a couple, see what we have time for here. So, and then those of you who feel like you're ready to roll on your own, you can. Today's assignment is going to be a little bit different. We haven't done many assignments like this in this class. So bear with me here. But it's more kind of your traditional worksheet style problem or homework assignment. It's not a big ideas, it's not an IXL, it's its own thing. So if you look at the assignment in Google Classroom, you'll see 9.6 worksheet, right triangle word problems. So it's all about angles of depression and angles of elevation. And so for the first page, it gives you a pretty clear right triangle. It shows you what's going on in the problem. It shows you what you're supposed to solve for, all that good stuff. And there's 4 problems on that first page. The second page has 5 problems, and they do not have pictures drawn for you. You get to figure out the picture. But it's got stuff like the ladder problem. It's got a couple of ladder problems, actually. Or an angle from a tower, or a tree casting a shadow, or a building casting a shadow, that kind of thing. So that's what we're working with. If you're looking at the casting a shadow problem for the tree or the building, you can kind of use this as a model. We've got a shadow going on from a tree. But yeah, so that's what we're working with here for our homework today. It's 11 total problems. And once we kind of start to get the hang of these do go faster. So at this point, if you would like to go and work on your own, you can. If you would like to stick around and do 1 or 2 of these with me, you also can stick around and do 1 or 2 of these with me.